Today we're going to be talking about simplifying and rationalizing limits. In this first example right here, you're going to notice a binomial divided by x. We are trying to find the limit as x approaches 0. If you think about what's going to happen if we try and plug in 0, we're going to be getting something divided by 0, which by now you know we cannot do. If you take a look at the equation in general, you may notice that simplifying might be a good solution in order for us to get an easier answer. So I'm going to go ahead and I'm going to simplify the numerator just so that we can see if there's any way that we can cancel anything out and maybe try and get rid of that x in the denominator. So I went ahead and I FOILed out the numerator, and then the plus 4 and the minus 4 canceled each other out, and what I'm left with is x squared plus 4x all divided by x. Now, what I notice right away is that if I'm trying to get rid of the x in my denominator, I absolutely can factor an x out in my numerator because I do have an x in both terms. Now, when I take a look at this, my x's can cancel out, and all I'm going to be left with is an x plus 4. Now that those x's have canceled out and I no longer have that x in the denominator, I can go ahead and I can plug 0 in, and I am going to be getting an answer of 4. Now, if I want, I can go ahead and I can put equal signs in here. I do just need to make sure that I'm putting them in front of everything. So again, with this example, we're going to notice that if we go ahead and try and plug limit as x approaches 3, if I go ahead and try and plug 3 in there, I'm going to get something divided by 0, which we know is not allowed. If I take a look at what's happening in this question, though, I can see that if I'm getting a common denominator in the numerator, there's a possibility of potentially canceling out some things that is going to make my life a little bit easier. So I'm going to go ahead and I'm going to simplify this. And in order to do that, I do know that I need to get a common denominator in my numerator. So what I'm going to do is I'm just going to rewrite this. This step is not necessary, but it is helpful for a lot of people just to kind of see what's going on in a different way. So when I do this, and I'm just going to use a different color of ink here, when I get a common denominator in my numerator in the first term right here, I know that I need to take each fraction and multiply it by something so that I get this common denominator. So my common denominator in this case is going to be a 3x. So in this first term, I need to multiply my numerator and my denominator by 3, and in the second, I need to multiply my numerator and my denominator by x. So what I'm going to get when I do this is the limit as x approaches 3 of 1 times 3 is 3 over 3x minus 1 times x is x over 3x divided by x minus 3, and I'm going to go ahead and just put it over 1 right now. So the limit as x approaches 3, I'm going to combine these. So 3 minus x over 3x divided by x minus 3 over 1. Now, some of you might be saying, whoa, Miss G, what's going on? These are not the same. I have a 3 minus x, I have an x minus 3. I can't do anything with that. I'm going to go ahead and I'm going to do 2 steps kind of at once here. So I know that 3 minus x and x minus 3 are not the same, but I can also recognize that they're the exact same with opposite signs. So I'm going to go ahead and I'm going to factor a negative out of this one, and when I do that, I am going to get x minus 3. And in the same line, I'm going to go ahead and I'm going to change this division to a multiplication by the flip. So instead of dividing by x minus 3 over 1, I'm going to multiply by 1 over x minus 3. So the limit is x approaches 3. I am going to multiply this negative x minus 3 divided by 3x times x minus 3. I can see that this and this are going to be canceling out, and I'm going to be getting the limit as x approaches 3 of negative 1 over 3x. Now, I can go ahead right now and I can plug that 3 in because I will no longer be dividing by 0. And I'm going to get an answer of, and I'm really sorry I'm running out of room, an answer of negative 1 over 9. Now again, I can go ahead and I can add, oops, change to red there, add those equal signs in the far left. In this next example, we're going to be talking about rationalizing. Knowing how to rationalize an expression is going to become really important when we are dealing with any kind of function involving these radicals. In this particular example, what you're going to notice is that, again, we have the limit as x approaches 0, and we have an x in our denominator. So again, we're not able to just plug in a 0 and get an answer like we have been able to in the past two examples. We are going to have to simplify this a little bit, and in order to simplify this, the only thing that we can do is rationalize. In this particular example, not only if we plug in 0 are we going to get a 0 in the denominator, we're going to get a 0 in the numerator. So we're going to be getting 0 divided by 0, which is an undefined expression. So in this example, we have the square root of x plus 1 and then subtract 1, all divided by x. Now, some of you might not remember rationalizing, some of you will. What we need to do in order to do this is multiply by the exact opposite of what we have. So I'm going to go ahead and I'm going to write this multiplying. I'm going to add these brackets in. Now I have the square root of x plus 1, and the exact opposite of this minus 1 that I have right here is a plus 1. Now I know that if I multiply that on the top, I have to do that on the bottom as well. Now before I move on, I did just want to quickly mention that this right here, this exact opposite term, is called a conjugate. Sorry. Now that I'm multiplying by this conjugate, what I can do is I can just start foiling like you normally would. So the limit as x approaches 0. I have my first two terms, the square root of x plus 1 times the square root of x plus 1. So you know that when you're multiplying two terms that are identical and they're both square roots, we are just essentially eliminating that square root. So for example, root 4 times root 4 is just 4, or root 9x times root 9x is just 9x. So the square root of x plus 1 times the square root of x plus 1 is just x plus 1. Let me just get a different color here. So then what you're going to notice is we are going to have the square root of x plus 1 times plus 1. And because we're multiplying by the conjugate, I'm not going to write that because I notice that my next term after that would be the square root of x plus 1 times minus 1. And those two terms will just cancel each other out. My fourth and final term is going to be this negative 1 plus 1. Now I'm going to go ahead and I'm going to just rewrite the bottom here. So the square root of x plus 1 multiplied by that x. Now if I simplify this numerator, I'm going to get x divided by x times the square root of x plus 1 plus 1. I can very clearly see that these x's are going to be canceling each other out, and I'm going to be left with the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. Now if I think about what's going on now when I plug in 0, I am getting a term that is okay. So I'm going to get 1 over the square root of 1, which is 1 plus 1, and I'm going to get 1/2.